Tonight we're going to find out more about the contentious and somewhat confusing issue of fluoride in our drinking water. And just a quick heads up that next week we'll be exploring the issue of the privatization of many aspects of our healthcare system. So we encourage you to register on Eventbrite for that as well. These gatherings are sponsored by Windsor Essex On Watch, WOW, which was launched over a decade ago on the traditional territory of the Anishinaabe people of the Three Fires Confederacy, Ojibwe, Potawatomi, and Odawa. We recognize that all of Canada resides on traditional, unceded, and/or treaty lands of First Nations, Inuit, and Métis peoples, and we are grateful for their ongoing care, respect, and love of the land, air, and water that we now share. And we endeavor to actively support the calls of action to put forward by the Truth and Reconciliation Commission. So we're planning to keep tonight's event to an hour. You'll have the chance to ask Dr. Till questions in writing about her research via the Q&A down at the bottom of your screen. We do ask that you use the Q&A only for questions rather than making comments, which can be a bit distracting. But feel free to write in your questions as they come to you, and we'll get to as many of them as we can. But first, I would like to introduce Kimberly DeYoung. She is the Deputy Mayor of Kingsville and the Program Director of the Kingsville Community Center. She's also a mom. About 15 years ago, Kimberly started wondering why fluoride hadn't prevented her young daughter's severe cavities. She started researching and came to the conclusion that the science on fluoride and municipal water fluoridation is far from settled. We've invited Kimberly to introduce Dr. Till, our guest speaker this evening. Kimberly?
Thank you, Margaret. I have the honor of introducing Dr. Christine Till. She's a professor of psychology at York University, a clinical neuropsychologist and adjunct scientist to the Neurosciences and mental health program at SickKids Hospital in Toronto. She's the 2019 recipient of the President's Emerging Research Leadership Award. Dr. Till's research aims to understand the neurotoxic and endocrine disrupting effects of fluoride exposure in pregnancy and across the lifespan. Her fluoride research is funded by the National Institutes of Environmental Health Sciences and the Canadian Institutes of Health Research. I've had the pleasure of hearing Dr. Till present before. We're very fortunate to have her here tonight to discuss the current state of evidence-based research on fluoride neurotoxicity. Thank you for joining us and welcome, Dr. Till.
Thank you very much for that introduction and the thoughtful land acknowledgement. Let me get set up here. Does that look okay? You can see the main page. Let me just minimize all of this so I cannot see the chat right now, but that's okay. Okay, thank you again, Philippa, for the invitation, to Brandy for setting up this webinar, and to the audience for your interest in research on fluoride neurotoxicity. Philippa actually reached out about a year ago and asked me to present to this group, and I said, sure, I'll present after a major report comes out by the National Toxicology Program, which we were expecting last May 2022, but it didn't come out. It was held up for political reasons, and then it was finally released in March under a court order. So then Philippa reached out to me again, and here I am. So it is my pleasure to discuss with your group the current state of epidemiological research on fluoride neurodevelopmental neurotoxicity, including some of the work that I've been involved with. And I'll begin by saying I have no financial disclosure or conflicts of interest with the presented material. So when talking about fluoride, it is important to distinguish between topical and systemic sources of fluoride. Topical sources include toothpaste, mouthwash, fluoride gels. These products are used for the prevention of tooth decay, and of course, they're not intended to be ingested. Systemic sources include fluoridated water or fluoride, like water-based beverages, as well as some foods and drinks like black tea, which is a hyperaccumulator of fluoride and can have high concentrations of fluoride depending on where it is grown. In some parts of the world, fluoride in the soil can be quite high. So this is an important source. Other foods include grapes, which derive the fluoride from pesticides that are used, fluoride supplements, sometimes prescribed to young children, as well as some pharmaceuticals like sevoflurane, which is a commonly used anesthetic. This figure shows the percentage of fluoride intake from various sources like water, beverages, and so on. The purple or lavender bars represent the proportion of fluoride intake from water, and yellow from the beverages. So you can see that the major source of fluoride intake is from water and water-based beverages. But there are some other important sources to take note of, in particular in young preschool-age children. Toothpaste is an important source of fluoride intake, of course, because it is flavorful and bubblegum flavor, and these kids are often using too much, as indicated by this article based on US data from 2013 to 2016, showing that 38% of children between the ages of 3 and 6 years use more toothpaste than recommended. The recommended amount for this age range is only a pea size, and for children under the age of 3, it's about a rice size or just a smear. Now, in Canada and the United States, the optimal concentration of fluoride in drinking water is currently set at 0.7 milligrams per liter to protect against tooth decay. This compares against the much lower level of naturally occurring fluoride that is found in most fresh water of 0.05 milligrams per liter. But of course, this can range to much higher levels depending on the geology of the area. So you can have some areas with higher levels of naturally occurring fluoride. In Canada, the maximum amount of fluoride that is allowed in public water systems, also called the maximum allowable contaminant level, is 1.5 milligrams per liter, and that's also what the WHO uses as the maximum level. This map shows that approximately 39% of Canadians on municipal water systems receive fluoridated water. The fluoridated coverage has been pretty stable over the past 15 years or so, but has been coming down. So if you go past like into the early 2000s when it was a little bit higher, you can see it does vary from province to province, with really central Canada having the highest rates of fluoridated water. And since the 1950s, community water fluoridation has been widely endorsed by public health officials as a safe and effective way to reduce tooth decay. The Center for Disease Control states that it reduces tooth decay by at least 25% in children and adults. Now, while this public health practice is considered one of public health's greatest triumphs, it is also one of its most controversial. And this controversy started from the very beginning when community water fluoridation was first adopted, and it is still not settled. So what is the fuss about fluoride? And I really like the title that was used to advertise this talk. And that's what I'm going to focus on, trying to explain why all this fuss and why the controversy. But to understand the controversy, it is important to look at some of the history related to community water fluoridation, starting with the 1940s when fluoridation was first introduced. In fact, one of the cities that was part of the initial set of studies showing that community water fluoridation is effective in preventing caries was Brantford, which is not too far from here. So that was started in about the mid-1940s. By 1960, over 50 million people in the US were receiving community water fluoridation. And it was in the late 60s when fluoridated toothpaste comes on the market. And that's an important point because prior to this, fluoride in drinking water was really the main and only source of fluoride. By the 1990s, health studies on fluoride began to appear. And then in 2006, a very important document was published by the National Research Council reviewing the health effects of fluoride. And this document concluded that high levels of naturally occurring fluoride in drinking water may be of concern for neurotoxic effects. And the report concluded that more research was necessary, especially for vulnerable populations like pregnant women. And really, it was over 10 years later after the publication of the NRC report when we see our first prospective birth cohort studies published. The first two came out of Mexico, and then our study out of Canada in 2019. In 2020, a landmark federal trial against the US EPA was launched, and it is still ongoing. And then in 2023, another major report was released by the National Toxicology Program examining neurodevelopmental effects of fluoride. And I'll talk about the results of this report in today's presentation. And I should also add, because many of you are from Windsor, this has been a very hot topic in Windsor, with Windsor stopping fluoridation in 2013 and then reinstating community water fluoridation in 2022. So my aim today is to discuss the epidemiological research on fluoride developmental neurotoxicity. I'm going to review some of the health outcomes, including intelligence, ADHD outcomes, as well as thyroid hormone disruption, and then take a look at some vulnerable populations. So in 2019, our group published the first birth cohort study in a Canadian population receiving optimally fluoridated water. This was a cohort study, and on the pyramid of or quality of evidence from an epidemiological design, a cohort study is considered to be higher quality relative to cross-sectional designs or ecological studies. The one design that would be higher quality, of course, would be a RCT, but this would be unethical to expose pregnant women, one group to fluoride in their water and another group not to. So having a cohort study is the next best level we can do for this type of epidemiological research. So this study used a sample from the Maternal Infant Research on Environmental Chemicals, or MIREC. This is a database owned and operated by Health Canada scientists. We studied 512 mother-child pairs recruited from 6 cities across Canada. About 40% of the sample lived in a fluoridated region. We had 3 measures of fluoride exposure. Our gold standard measure is urinary fluoride. This was based on a spot sample that was measured in each trimester, and then we adjusted for urine dilution and took the average overall across the 3 trimesters. Our second measure is fluoride in drinking water, and this was obtained from drinking water measurements from the water treatment plants that serviced the residences of the women included in the study. And we took care to ensure that women drank tap water and resided in the same area throughout her pregnancy. And the third measure was fluoride intake, and this was based on number of cups of coffee, tea, and water the woman reported drinking throughout her pregnancy. Now, this figure shows that urinary fluoride levels are about 2 times higher among pregnant women living in fluoridated versus non-fluoridated communities. So as you would expect, and what's interesting is the urinary fluoride level, the concentration is on average about 0.7, and that's typical that it relates close to the concentration found in drinking water. But it's also important to note that the women living in the non-fluoridated communities also have fluoride detected in their urine, and that reflects the other sources of fluoride that are commonly found in foods, dental products, and so on. So with increasing levels of water fluoride, we see increasing levels of urinary fluoride. Sometimes we refer to our measure of urinary fluoride as MUF. That's our acronym for maternal urinary fluoride. But on the right, you also see this moderate correlation with higher levels of water fluoride. We see higher levels of fluoride measured in the amniotic fluid, and this reflects how fluoride passes from maternal blood into the placenta where it reaches the fetal brain. Okay, so next I'd like to talk about some of the fluoride IQ relationships, and I'll start by talking about what we found in the Canadian sample that I was just describing. And this was work overseen by my graduate student, Ripka Green. And what we found was that with higher levels of urinary fluoride, child IQ decreased, and this effect was found in boys, but not girls, with a coefficient of 4.5 IQ points. So that's a pretty large IQ decrement. Likewise, with water fluoride concentration, with increasing levels of water fluoride, we found a decline in child IQ, and this was found in both boys and girls of about 5 IQ points. And with fluoride intake, we found the same inverse association, higher levels of fluoride intake and lower child IQ. I should also note that all of these associations were controlling for important covariates like the home environment, the sex of the child, maternal education, race, secondhand smoke, and city. So to summarize, a 1 unit increase in fluoride exposure was associated with a 3.5 to 5 IQ point decrement. And that's a fairly large effect size comparable to what we would see with lead. A lot of people ask, is 1 milligram per liter a high level of exposure? And just to put into context, if you look at the distribution, if you have 100 women living in a city like Windsor that adds fluoride to drinking water, you would have about 14% of women having a concentration of 1 milligram per liter or higher found in their urine. So a 1 milligram per liter is not a very high level. It's definitely found in our Canadian population. So after much deliberation, we concluded that the findings indicated the possible need to reduce fluoride intake during pregnancy. This recommendation was based on the consistency of our findings across our different exposure measures, but also with the other studies that had been published at the time, as well as the strength of our findings. When the paper was published, it was published along with an editorial, as well as a first ever editor's note describing the decision to publish the study, as well as a podcast with 2 JAMA Network editors talking about the significance of the findings. And you can see from the excerpts from these 2 editors, the shock or the disbelief, which was the typical reaction by most people. Not surprisingly, the results were also startling to others as well, and the study received quite a bit of press, but also a lot of backlash, as shown by this title here. So critics attacked the methodology of the study and discounted the significance of the results. We often heard it is only 1 study, but this was simply not true. At the time of our paper being published, there were 2 other birth cohorts that had been published prior to ours, as well as dozens of other studies reporting concerns with neurotoxic outcomes. So we immediately found ourselves at the crossfire of an attack on science. So now I'd like to switch and talk about the National Toxicology Program's report that was recently released. This is still a draft report, but as I will soon describe how many revisions it's been through, I think it's fair to say that we can look at this document and take some meaningful conclusions away from it. So the NTP conducted a massive systematic review to assess the scientific studies on fluoride exposure and potential neurodevelopmental and cognitive health effects on fluoride. The NTP identified over 500 studies that they found relevant to this topic or to thyroid-related health effects. Of these, 159 studies were conducted in humans, and they also looked at some animal and in vitro studies to inform on potential mechanistic data. So from the systematic review, they then conducted a series of meta-analyses using child IQ as the primary endpoint, and I'll describe those outcomes next. So just to talk about the process and how this report has evolved since 2019, when the first report was released. This report was then subject to a peer review by an expert committee that was convened by the National Academies of Science, Engineering, and Medicine, or NASEM. And after that first report, the committee came back and recommended that the NTP present its analysis more clearly and transparently. So the NTP, or sorry, the NASEM committee was really charged with reviewing the NTP's process, their communication of the findings to ensure that the findings were clearly stated and objectively presented. So the NTP went back, they revised the document, and then they released version 2 in September 2020. And again, the NASEM committee reviewed that report and concluded at that point that further analyses were needed to support the conclusions. So the NTP went back again to revise their monograph. This time they came back with another systematic review, but they also included a meta-analysis that would be submitted to a journal for publication. So this revised document, version 3, I'll call it, was revised and was ready to release in May 2022, but then it was held up because the head of the NIEHS decided that they needed to convene another committee to review the NTP's responses to this peer review. So this is like going like really, really high level to now see, did they adequately address the comments that they were asked to address. So that's what took, this past year. The NTP then went back and has received some feedback from this other, the board of scientific counselors, who said, these are some comments that you can do better on. So that's where we're at now, as the NTP is continuing to refine this draft document. So I have to say that this is an incredibly impressive accomplishment of these scientists who conducted this work to ensure it has scientific rigor and a balanced representation and clear communication. So in terms of the process that was followed, this 5-step framework adopted by the OHAT, if you're interested in the process, is shown here. But step 4 is a level where it's extremely important when it comes to fluoride and doing any type of meta-analysis, because what happens is every single study is subject to careful characterization on its risk of bias. So they will look at the exposure assessment, the outcome assessment, whether the statistics were appropriate, what type of covariates were controlled, and so on, to determine whether the study has a high risk of bias or low risk of bias. So that was step 4. They did that for every single study, and you can go to the document and review what they thought of every single study that has been done on this topic. But then there's step 5. And this is taking another step back to rate the overall confidence on the overall body of the evidence. So at this point, the NTP was asked to decide whether, looking overall, if the results are consistent across the studies, that would increase our confidence in the conclusions that were made, as opposed to, let's say, the findings are all over the place, that would then knock the confidence rating downwards because overall the pattern would not be as consistent. So then they did this like extra step. And this reminds me of a quote from a decision-making scientist in the psychology literature that said something like, "We don't have access to the truth. All we have to go on is our confidence." And I think this really reflects how important it is that we look at like overall, but it really does come down to how confident are we in this body of science. Really important that we weigh the high quality studies higher than studies that might have serious methodological issues. Okay, so looking at the results, I'll start with the first type of meta-analysis. This is a group level meta-analysis whereby studies compare a high exposure group to a low exposure group. On the left side, you see the list of the studies that were included in this meta-analysis. The solid line here represents an effect of 0, but any finding to the left of this line would represent a negative association or an inverse association, with higher exposure levels having lower IQ compared to the reference group. So first you see this overall consistent pattern of findings where most of the studies are falling to the left of the line. And then when you pool the overall results, so this is a standardized mean effect difference, meaning it's in standardized units. The overall effect, which is significant, is negative 0.46, and that translates to about 7 IQ points using an IQ scale that's typically out of 100. So that's a really large effect size overall. And you see there's remarkable consistency with 52 of the 55 studies showing this pattern. But it is important to look and zoom in on those higher quality studies. And if we do that, now there are only 10 of these studies. The effect remains significant, but the association is attenuated to about 1/5 of a standard deviation. So that's about 3 IQ points, which is still an important effect. The second type of meta-analysis is a regression slopes meta-analysis, and this takes individual level data. I think this is a more precise way of looking at the associations where the individuals were assessed for their fluoride exposure, typically in urine. And again, you see an overall effect that is negative and significant. So here it's negative 1.8. That's the decrement in IQ per 1 milligram per liter increase in urinary fluoride. So again, the inverse association is found using urinary fluoride. And the third type of meta-analysis is called a dose response mean effects meta-analysis. This is a bit less conventional type of meta-analysis used in epidemiological studies. It doesn't take advantage of individual fluoride exposure levels as you would with a benchmark dose. But basically what they're plotting in this curve up here, this is the difference in IQ from 0. So the decrement in IQ score by water fluoride variables, and you do see water fluoride concentration. And what you see is this negative trend, is quite a steep trend in the lower exposure levels. This is based on 29 studies with water fluoride exposure, based on at least a high and a low exposure level. And then looking down at the bottom curve, again, you see this negative association. This was based on 18 studies with urinary fluoride exposure. And there's been a lot of discussion about focused on the lower end of the exposure. And if we look at the studies that had urinary fluoride levels that were in the lower range, we're down to only 6 studies, and the association does remain significant if we only look at those 6 studies. Okay, so what did the NTP conclude? Well, first, they said that the pattern of results across the 55 studies was consistent, with 95% of them reporting an inverse association. They ran a number of subgroup analyses by sex, age group, study location, type of assessment, or type of exposure, and so on, and found a consistent and robust pattern of an inverse association between fluoride exposure and children's IQ. So there's been a lot of pushback, people saying, well, most of these studies were done in communities with much higher levels of fluoride exposure, which is true. The NTP responded to that comment by saying, but we have no basis on which to state that our findings are not relevant to some children or pregnant people in the United States, because they also included studies that were done in areas with fluoridation. But also, as I will point out, when we look at urinary fluoride, we're not just measuring the fluoride that comes from the water, we're measuring fluoride from all the sources. So it's a bit ridiculous to only look at urinary fluoride levels that fall below 1 milligram per liter, because in our general population, at least in Canada, and now we know in the US, we have that data as well, that concentrations of fluoride exceed 1 milligram per liter. So it doesn't really make sense to only look at very, very low levels of urinary fluoride. That doesn't represent the general population. So should we care about a few IQ points? Absolutely. If this figure shows a distribution of IQ scores based on US distribution of children, with over about 6 million children falling in the challenged range and that many children falling in the gifted range. But if we shift that entire population down by 5 IQ points, we would have 9.5 million children falling in the challenged range and that many fewer children in the gifted range. So this is a staggering effect at the population level, given the number of people who are exposed to fluoride in water as well as other sources. So some other health outcomes that I would like to talk about today include attention deficit hyperactivity disorder. And this is another area that I've been studying, starting with an ecologic study that we did in the US. We did find an association with fluoridation and ADHD, but this was an ecologic study and we needed to do better. In Mexico, the study looked at individual levels of urinary fluoride. It's plotted here, and we found that higher levels of urinary fluoride was associated with a higher score of ADHD-like symptoms as reported by parents. And then in Canada, we did another study. This was using Stats Canada data, again found an association between higher tap water fluoride concentration was associated with a higher prevalence of ADHD. Recently, another study came out of Australia. The study did not find an association between lifetime exposure to fluoride in water and attention hyperactivity when those two symptoms were combined on a parent questionnaire. This is kind of more hot off the press study overseen by my graduate student, Anna Radmilovic. And this is based on the MYRIC cohort, and it's based on 3 to 4-year-old children. But what we have found is that higher levels of urinary fluoride in pregnant women is associated with elevated symptoms of hyperactivity, but not with attention problems. And this was based on parent report when the children were between 3 to 4 years of age. We are just waiting for that same questionnaire to be it has been completed when the children are a little bit older. So we'd like to now see whether this association remains as the children are older. So we're just waiting for that data to arrive. Water fluoride did not associate with these outcomes, on the other hand. So the ADHD findings are very interesting to me because they link back to this classic paper by Phyllis Mullenix from 1995, where she studied behavioral outcomes and brain changes in rats that were exposed to fluoride at different time points in development. And what was intriguing to me in the study was that the behavioral signature of fluoride differed depending on sex, but also with timing of exposure, with the male rats being most sensitive and showing hyperactive symptoms when they were exposed prenatally, whereas the female rats showed the behavioral signature when they were exposed as in the weanling or adult period. Okay, so moving on to another health outcome that is also very important, and this is some of our more recent research looking at fluoride and thyroid function in our Canadian pregnancy cohort. Disruption of thyroid hormone is a potential mechanism underlying developmental fluoride neurotoxicity. Fluoride is thought to interfere with thyroid hormone metabolism or thyroid hormone formation, or even transport of thyroid hormones into the cell. But no studies had been conducted in pregnancy. So we looked at whether our fluoride measures in water, urinary fluoride, and fluoride intake were associated with a diagnosis of primary hypothyroidism in our cohort. And then from there, if we wanted to see if women who were hypothyroid had children with lower IQs. So in this sample, it was over 1,000 women. We looked at what we found was that higher levels of fluoride in drinking water were associated with a higher risk of hypothyroidism. The effect size was quite high, an odds ratio of 1.65. So that's roughly a 65% increase in the risk of having hypothyroidism for every 0.5 milligram per liter increase in fluoride. We also adjusted for important covariates and ran a number of sensitivity analyses, and the results remained significant. Now, we did not find an association between our outcome, hypothyroidism, and our other fluoride measures of urinary fluoride. Fluoride intake trended towards significant finding. This is an important outcome because thyroid hormone is known to be critical in gestational development, particularly during the first trimester of pregnancy when the fetus is completely reliant on maternal thyroid hormones. If the fetus does not receive adequate thyroid hormones from the mother, this could be one mechanism underlying the previously found association between fluoride exposure and child IQ. Now, hypothyroidism in turn can affect children's learning ability. So we looked at the IQ of the children born to women who were hypothyroid, and we found that the boys whose mothers were hypothyroid in pregnancy had significantly lower IQs compared to the women who did not have hypothyroidism, but we did not see that association with the girls. Okay, so now moving on to vulnerable groups. And the first group I wanted to talk about are formula-fed infants. So this figure shows daily dietary intake of fluoride by age group in infancy. The green line shows the average intake from breast milk, and the dietary intake level of fluoride is very low in breast milk because of the limited transfer of fluoride from plasma into breast milk. So babies who are breastfed compared, or babies who are formula fed, when the formula is made with fluoridated water, have over 10 times the dosage compared with a breastfed baby. So now if you're making formula that's reconstituted with non-fluoridated water, of course, the fluoride intake for the infant would remain low. So this red line shows the Institute of Medicine's tolerable upper intake level, which is defined as the highest level of intake that is likely to pose no adverse effects to almost all individuals in the general population. But exposures that exceed this upper level, which do occur in the first 6 months of life, at least for bottle-fed infants who are given fluoridated water for their formula, they are at increased risk of adverse effects. And the main adverse effect that we're talking about in this case is enamel fluorosis. And this meta-analysis does show that formula-fed infants, and these are infants given formula made with fluoridated water, are at increased risk of enamel fluorosis, which is this white opacity that can appear on the permanent teeth, and it results from exposure to fluoride that occurs in early development. So this really is the elephant in the room for us, because we have evidence that fluoride is entering fetal tissue into the teeth early in development. So what about it entering the fetal brain? I also wanted to point out that the percentage of infants exclusively breastfed for the recommended 6 months or more, which is the recommended amount of time set by the WHO or the American Academy of Pediatrics, is reported to be about 34% in Canada and only 25% in the US. And of course, we would expect lower rates among socially and economically vulnerable women. So put another way, about 65 to 75% of infants who receive formula in the first are receiving formula in the first 6 months of life. So we did a study that derived a fluoride intake variable. This was based on when formula was introduced and what type of water was used to reconstitute the formula. Our outcome here is performance IQ, which is a measure of nonverbal intelligence. And you can see that there is a negative association and the effect size is quite large. So just to clarify what I'm showing here, a breastfed child would be here, very low fluoride intake in the first 12 months of life. But you would also have a formula-fed baby on this side if they were given formula made with non-fluoridated water, whereas an infant who was given formula from day one would be here if they were living in a fluoridated community and using tap water to reconstitute the formula. And this association was controlled for important covariates, but it also remained significant after controlling for fetal fluoride exposure. So we concluded that in the absence of any dental benefit from fluoride consumption before teeth erupt, because fluoride works predominantly after the teeth erupt, it is prudent to limit the use of fluoridated water for infants. Okay, and finally, another vulnerable group that we've been looking at is iodine deficiency, or people with a low iodine status, which can also be a risk factor for fluoride neurotoxicity. So we know that adequate iodine intake is essential for normal thyroid hormone synthesis and normal thyroid hormone function, which in turn is critical for fetal brain development. Studies in China have found that children living in high fluoride and iodine deficient areas had lower IQ scores than those living in areas with high fluoride or iodine deficiency alone. Moreover, recent trends show that iodine deficiency in pregnant women iodine deficiency in a good proportion of pregnant women in the USA, as well as in women of childbearing age. And this was a study done by a colleague from Health Canada. And you can see that the iodine level overall for women between the ages of 20 to 39 in Canada is on the low end, where 150 is typically known as adequate level at the population level. So what Carly Goodman did, another graduate student in the lab, she looked at the slope of the fluoride IQ association in children whose mothers had low levels of iodine in pregnancy versus adequate levels of iodine in pregnancy. And what we found was that that slope between fluoride and IQ was steeper in the low iodine group compared to the adequate iodine group. So overall, we concluded that iodine deficiency in pregnancy may increase the risk of fluoride neurotoxicity. Okay, so what is the fuss all about? So at high exposure levels, there is no question that fluoride is a neurotoxin. But the debate and this ongoing lawsuit really is centered on the question of whether the scientific evidence for low fluoride exposure levels is sufficient to support a hazard classification. Like, can we call fluoride a presumed or suspected neurotoxin based on the data we have? So right now, public health regulators are saying that 1.5 milligrams per liter is harmful, too high, but a little bit is okay. So that's where we're at today. But I'd like to return to this figure that clearly shows that as IQ drops, as fluoride exposure increases. And again, point out that really the range is not, in my opinion, only, we don't need to only care about people who fall in this very low range, because if we look at the population level of urinary fluoride values across Canadians living in fluoridated communities, the range is more like from 0 to 2.5 milligrams per liter. So I don't think it's a strong argument to say that we only care about the very low exposure levels when we have, in a place like Canada and the US, higher exposure levels when you consider all the sources of fluoride. We definitely need more research looking at areas with optimally fluoridated water. But the point is, when we are measuring the biomarker, which is really a stronger predictor, because water fluoride, just because there's fluoride in the water doesn't mean someone's drinking it. Maybe they drink juice or something else all day. So measuring it in the urine or other biomarkers, toenails, whatever, is, in my opinion, a stronger, more precise measure of what the person is actually exposed to, as opposed to saying, oh yeah, there's fluoride in the water. We should be looking at what they're exposed to and including other sources. Okay, so some final thoughts. Given the current state of the science, and by here I'm referring to the robust and consistent associations as shown by the NTP report, the potential for adverse health effects of early life exposure to fluoride are of huge public health significance. There are millions of people exposed to fluoride in drinking water, and given the ubiquity of fluoride exposure, the population impact of these potential adverse effects is estimated to exceed those associated with other toxic elements like lead or arsenic, because we have a huge population of people exposed to fluoride. Secondly, we know a lot about fluoride. We know about the sources of fluoride. We know about how it works and when it works to prevent tooth decay. We know that too much fluoride can impact thyroid hormones, and we know that thyroid hormones play a critical role in brain development. So we need to communicate this information to the public, and if we fail to do so, and just continue telling everyone that it is safe for everyone at all stages of life, this can risk eroding the public's trust in public health. So, and finally, if we don't act, this can amount to enormous costs at the population level. So I'd like to conclude by saying we can focus on action. At this point, we recommend reducing the risk of neurotoxicity by considering fluoride intake from all sources, especially among pregnant women and infants. And last but not least, I would like to acknowledge my team of co-investigators, especially Bruce Lanphier, my co-PI on many of the studies that we've been doing, my amazing team of students and postdocs, Myrick for providing us with the opportunity to work with this tremendous database, the staff at the laboratories that analyze the thyroid hormones and the fluoride measures, and as well as our funding sources by the NIH and CIHR. So thank you so much for your attention.
Thank you so much, Dr. Till. This was really informative, and I've learned a large amount. I think that the information that you presented is material that most average people just don't have access to. It's usually much more dry, and this all your slides were really interesting, and I think that we're all going to benefit from the recording, so we can go back and look at this material again. And I did make a note on slide 49. Like, to me, that was the most important one, or at least the most striking. That was the one where you showed the tolerable upper intake levels, and you could see that by the age of about 6 months, or below the age of 6 months, there was a very stark difference, or at least that it was above the upper tolerable level. We do have a number of questions that have come in, and I'm hoping that we have time to address them all. The first one came in from New Zealand, but I do think it's also a question that's relevant to us here in Canada. And Kane says that New Zealand has just introduced mandatory fluoridation, with the Director General of Health able to issue a directive to council areas in New Zealand. Now, this is new to me. 14 council areas have currently been directed to fluoridate, with an additional 27 councils being considered. Can you comment on whether a pause should be put in place in the extension of fluoridation in New Zealand until the NTP research can be reviewed and acknowledged?
It's a great question, and a lot of people ask, where to go from here. I'm not a policymaker, and this is where I will say that I hope our research is used to advise policy and really to weigh the risks and the benefits. So I presented the research on potential risks. This is where, to just say based on this, isn't looking at all the facets. I think counselors also need to consider the research on the benefits as well to make these decisions. So I'm going to leave that up to the policy analysts.
Now, the next question is a little bit rhetorical, I think. The question is, why is water fluoridation so important? If there's even a doubt about its harms, then why would we need this mass supplementation of a known neurotoxin? Why? The benefits of ingesting fluoride for dental caries is very dodgy anyway. And I know we didn't want to get into the dental health aspect of this, but I think that the person makes a good point.
Why?
I don't know if you'd like to comment on that.
Yeah, I mean, I think this is an intervention that's been around for a very long time, and there's some dogma here where even me, when I started this research, I thought it was safe and effective. So it took a lot of studies for me to look at the evidence and say, wait a second, I have changed my opinion, at least on the safety front. That's what I've been studying. So I think the reason that it's still around is these beliefs are entrenched, that it's really, really effective. I think when it was introduced, it was the main source of fluoride, and things have changed now. We have alternative sources. So I think we need to factor that in as well. But I think the dental community is very proud of this public health intervention, and so I think it goes back into why it was so popular when it was here, and how it takes a long time to change those beliefs. And yeah, so that's my answer of why it's still here.
Now, there's a two-part question from Dr. Dixon, and the first part references an article that I'm not sure if you've seen. He says, is Dr. Till willing to write or co-write a rebuttal to the recent major article in Canadian Family Physician, which repeated several times over safe and effective, and trivialized her and her colleagues' excellent research? So I'm wondering if we can maybe pull that article up and share it.
Oh yeah, no, I saw it. Yeah, I could spend like all my hours writing rebuttals to things. They're like weekly. Yeah, I encourage like anyone to write an opinion piece. This was a commentary. We are, I am working on another paper to talk about this issue. I don't want it to be a commentary. I want it to be a peer-reviewed paper so it is important, but I mean, this group feels strongly that it's safe and effective, and they trivialize our research and others. And, it's their opinion, and yeah. You can please go ahead, and I think someone else can start writing some rebuttals as well.
And I'm hoping some family physicians are here on the webinar, and perhaps they can reference some of your presentation in writing a rebuttal. Now, the next question from Dr. Dixon is something I had to look up myself. I'm not familiar with CADTH, which is Canada's Drug and Health Technology Agency, and he notes that the CADTH references in the recent article in the Canadian Family Physician Journal article so the references were from 2018 and 2019. And can Dr. Till comment on the current state of their position on fluoridation, since so little is to be found on their website?
Oh, I haven't looked recently. I know what I am aware of, SickKids did a rapid review of the Green et al. Paper that was published in JAMA Pediatrics. And we found a number of inaccuracies, and we wrote to the director of CADTH asking that those inaccuracies be corrected. And after our letter was sent, they removed the rapid report that called the Green et al. Study flawed. They had things like the sample size wrong. They said we didn't control for like parental education. We did. There were a lot of inaccuracies. So it was I thought a sloppy report. So they acted, they took it down. I'm not sure if they're revising the report. I'm not sure what happened to it, but I haven't seen it back up. So I can only speak to the report on our study.
The risk, of course, is that somebody who's read it, even if it's later retracted, the damage has been done if they've already drawn conclusions from the incorrect information.
Yeah, that's right. It does. This is a big issue in this field. There's a lot of not so great studies out there, or studies with inaccuracies that then get cited by other studies if they're trying to push their idea. So yeah, it is a big issue. I would recommend that every fluoride study be like the data analyzed by two groups that think differently. This is the only way that we can move forward. It's otherwise, there's a lot of bias in the field, and maybe this is one good that will come out of all of this debate, that we can come up with strategies to improve the science, because like bias really impedes scientific understanding and advancement if we just keep propagating beliefs rather than looking at the science objectively. So maybe that would be my recommendation for fluoride studies, that they be analyzed by different groups.
Now, I'd like to, so there's a question about fluoridated toothpaste, and I just want to reference something that you said right at the beginning, where you showed the pictures of how small the amount of toothpaste is. I don't think in all my life that I've ever seen the actual amount of toothpaste depicted. I've always known about the pea-sized amount, and in the ads on TV, they always have a big fat slurp of toothpaste. But this is the first time that I read it. So the question is, many toothpastes are also fluoridated, and what does the industry say about that? And then there was also a secondary question, and that is, do you have an explanation for the differences in risks between boys and girls?
Yes. Okay. So the toothpaste, what does the industry say? I'm not sure, but there are a lot of people studying non-fluoridated alternatives. And there's a whole research body there looking at the efficacy of those products as well, that I would encourage listeners to look at as well. But won't go into, I'm not an expert on toothpaste efficacy. The next question about why the sex differences. Yeah, so this is really an important and interesting topic, and there are a number of mechanisms that might be accounting for sex differences. Carly Goodman, a student in the lab, has been researching this and just completed another systematic review looking at sex differences in relationship to environmental exposures. So this pattern is not unique to fluoride. We even see it with lead exposure, where the male brain appears to be more vulnerable to early life exposures. And why, I don't have the exact the reason why. There are different sex hormones, there's growth differences, there are like chemical genetic differences, even thyroid hormone transporters differ. They're on X-linked chromosomes. So this is a very, very hot topic today to look at. And now all studies that we are doing in environmental health require people to look at sex differences. And this is a big change, because if you look at studies done about 20 years ago, most of the studies, or many of the studies, did not even look at differences by sex. But we are finding very big differences, even in animal studies. So I think the mechanism as to why depends on the exposure type and timing of exposure as well. So I think it is such a critical point, though, when we are looking at meta-analyses, that when we lump everything together, like the prenatal studies and postnatal studies, the effects might actually differ by timing of exposure. So it would be important to look at the prenatal period differently from postnatal period, in my opinion.
So I think we have just enough time before we end this webinar to address one final question, which is very different. It's not something that you've spoken about, but how important would it be to advise people with kidney impairment not to drink fluoridated water?
Yeah, so that's another risk vulnerable group, because of course the kidneys are important for excreting fluoride, and there's some research to show that people with kidney problems are accumulating more fluoride and not excreting it as efficiently. So, I think, I'm not an expert on this, but in terms of like, it wouldn't harm you to not drink fluoridated water if you have kidney dysfunction, knowing the importance of the kidneys in excreting the fluoride. So yes, I would agree with that recommendation.
Of course, that's very relevant to us here, because we do have a large degree of kidney disease here, large prevalence, and so it's something that people should really be thinking about, I think. So there's another question that just came in. And the person is anonymous and asks, what can we do to demand more debate and change about fluoride corruption as taxpayers, community members, dental patients, etc.? I feel shut down every time I voice this concern to professionals. So much of our health is paid off, and their famous safe and effective sales point. And I'd like to, I mean, I can see the person's anger in this. But yeah. I do think that they make a point that we can all recognize.
Yeah, it's a great question. I wish I had the right answer for this question. So I think it is about like grassroots lobby groups, speaking to your like municipal councillors, getting, like as the city of Windsor has done, getting people aware of the science. It is still new science. We recently did a fluoride survey with undergraduates at York University. A thesis student did this, and I was shocked to learn that when we asked people why fluoride is added to drinking water, the majority of people had no idea, and they selected, to clean the water. So most people have, the average person that I speak to doesn't even know if there's fluoride in their water, let alone why. Some of the students didn't even know if fluoride is found in toothpaste, which I found even more shocking. So a lot of people, this is not on their radar. We need to do more to present this information about being shut down. I hear you. I'm when I go to the dentist, my children don't get the fluoride rinse because they do brush their teeth at home with fluoridated toothpaste. But I get that look of like, oh, you're one of them. So it's yeah, it's I understand what the feeling is like, that you're looked at like you're crazy when you bring up the topic. I do think the needle is shifting as more respected scientists are talking about this and taking the matter seriously. So it does take time. So hang in there. I'm going to say don't give up. It is really an important topic, and speak to people.
So I'm looking at the clock, it's 8:02, and I think we need to end the questions here. Now we are live streaming this on Facebook right now, and there will be a recording that we'll be distributing to all the participants. And I was also wondering if your slides will be available as well, Dr. Till, or would you suggest that people look at the YouTube recording?
Given we have some unpublished data in my slides, I'm not going to share the slides at this point.
Okay. Well, that's it for the questions for right now. So thank you very much.
Thank you so much.
That brings us to the end. Oh, I'm sorry. That brings us to the end of our event. And we thank you, Dr. Till, for your wonderful presentation. And we will probably look at the recording and decide what we're going to do next as a group. So again, we thank you very much. It was a very wonderful presentation and a lot to think about.
Thank you. Thank you so much for the discussion and the questions. Thanks for everyone for coming out tonight.
Thanks again. Take
My
care.
pleasure. Thanks.
Bye-bye.